This example asks us to find the equations of the tangent lines to two different functions. The first one is f of x equals 2 over x, and we're interested in the equation of the tangent line at the point 2, 1. Okay, well, when all is said and done, the tangent line is still just a line, so let's bring up the equation of a line. And we use the point slope version of the line, y minus y1 equals m times the quantity x minus x1. Remember, x1 and y1 are the actual points given, whereas y and x remain as variables, so we have 2 is our x1 here and 1 is our y1. So then all we need is our slope, and our slope will be given by the slope of the tangent line. So we'll write this as m sub tan. And there's a formula for that. Actually, we have two formulas for that. We have the x minus a version and the h version. Let's stick with the h version for these kinds of exercises, though both would do the trick. The h just seems a little more direct for this particular application. So here we have the slope of the tangent line is given by the limit as h goes to 0 of f of a plus h minus f of a all over h. And this is for the slope of a tangent line at a point a, x equals a. And quickly we'll replace this formula with a better one, a more general one that has x right here. So I'm not really a fan of this version of the tangent line because it's only good for one point, and we'll very quickly get one that's good for all points x that's way more general. So just keep that in mind as we do this, is we'll very quickly be getting a better way to do this that keeps that a as x, and then we plug in at the end. But for now we have this formula, so let's use it. So our a is this 2 here. The a is the x value. So a is 2, so I'm going to plug that in right off the bat here to the formula. So we have the slope of the tangent line, m tan, then is the limit, okay, as h goes to 0, of f of a plus h. So I'm putting in 2 plus h for x here in this, for f of a plus h. So we have 2 over 2 plus h minus f of a, so now I'm just plugging in 2 for x, so that's minus 2 over 2 all over h. And our goal with this kind of exercise is always to get rid of this h in the denominator because we're letting h go to 0, and we don't want 0 down in the denominator. So we want this h to cancel out. Alright, well, note that 2 over 2 is 1, so I'm going to replace this 2 over 2 with 1 right off the bat here. Okay, so we have 1 here. Alright, now we have this 2 plus h down in the denominator, so let's do a common denominator up top of 2 plus h. So that gives us, we'll do 2 plus h over 2 plus h here on the 1. So this gives us the limit as h goes to 0 of 2, well, so it's all going to be over 2 plus h, and then all over h, and then we have 2 minus the quantity 2 plus h. Now, when you have a fraction up top, up above another number like this, so let me do a simplified version of this over here. If you have a over b all over c, right, it just bumps down one layer, essentially, a over bc. A over bc. Why does that happen? Well, think of this as c over 1 and then multiply by the reciprocal. You can see it that way. So this is going to bump down one layer, and we'll combine these two denominators here. Note that also the 2's cancel out, so that simplifies to limit as h goes to 0. Let's see here. We now have negative h up top, and down below we have h times 2 plus h. And now we get that cancellation I was talking about, right? We finally cancel out that h in the denominator that goes to 0. We still have one down here, but it's not a problem. It's not forcing us, it's not giving us a 0 in the denominator. And now we're ready to evaluate our limit. We can simply plug in 0 for h to evaluate this limit. That gives us negative 1/2. And that is the slope of the tangent line. Let's go ahead and find the equation of the line then. We're back up to our formula here. Let's just plug everything into point slope form, and then we'll represent our answer in slope intercept form, y equals mx plus b form, that is. Okay, so let's clear out some space here. So we have y minus y1, which is 1, equals negative 1/2, that's our m, x minus 2, there we go, and let's just clean it up a little bit. Y minus 1 equals negative 1/2 x plus 1, and then finally solving for y gives us y equals negative 1/2 x plus 2. So there is the equation of the line tangent to the curve 2 over x at the point 2, 1. And note that if we change this point around to a bunch of different points, we'd get a different tangent line for each point. I mean, there may be some overlap, but in general, you move it around, you get different tangent lines as you move about the curve. Okay, let's try b. We have f of x equals the square root of x. We want the equation of the tangent line at the point 9, 3. Okay, we have the same idea here. We want to use the point slope form, so we need the slope of the tangent line. And we're given some starter points. We're given x1, y1 here, and our x1 is also going to be a. And again, this a business is odd. We will quickly begin using this formula with just x instead of a, and just do this a little bit more generally. So take this all with a grain of salt as we develop a more general approach to this. All right, so we need the slope of the tangent line. Let's do it. We have m tan, okay, equals that limit as h goes to 0 of, let's see, f of a plus h. Well, a is 9, so square root of 9 plus h, okay, minus the square root of a, so square root of 9, all over h. Okay, well, square root of 9 is simply 3, so I'm going to replace that square root of 9 there with 3, so that gets us somewhere. And now we have a radical along with the plus or minus. That's giving us a hard time. And there's a simple technique when that happens. It's called the conjugate trick. We have seen it before. So we'll multiply this by the conjugate. So that conjugate is square root of 9 plus h. And now we change the sign. So plus 3. And we do that over itself again because we're just multiplying by 1 here. Square root of 9 plus h plus 3. It's the conjugate. Super useful. Okay, well, let's multiply all these together here. All right, we have something like this. So up top, notice that the outside and inside terms will cancel out. We're essentially, foiling these together. Outside and inside will cancel. So let's clear out some room here. That leaves us with the limit. So we still have the limit as h goes to 0. And let's see, so square root of 9 plus h times square root of 9 plus h, the square roots undo each other, so we have square root times square root. So it's just 9 plus 8, outside and inside cancel, and then minus 3 times 3 is 9. All over, well, we fixed the top, but we really messed up the bottom. Look, h times square root of 9 plus h plus 3. Remember, our goal here in any kind of exercise like this, we're trying to get rid of this h in the denominator. We want that gone. And here we can see it happening. So look, our 9's cancel. We have 9 and plus 9 and minus 9. And now we can see that our h's cancel. Here's this h up top, canceling with the h in the denominator. So that's always what you want to keep kind of on your mind in the background. We want that h down in the denominator to cancel. So we have the limit now as h goes to 0 of 1 over, what's left here? Got so many things canceling. 9 plus h in the square root. Down below, plus 3. No, 9 plus h, not 9 plus 3. Getting ahead of myself there. Let's do this. Plus h. Okay, and now let's let h go to 0. We can simply evaluate this limit. We let h go to 0. It gives us no problems down below here. We're not dividing by 0 or anything here now that we got that other h to cancel. So I don't need to write limit anymore because I'm actually taking the limit. Once you take the limit, you stop writing the word limit. So I'm plugging it in. That gives us 1 over square root of 9, which is 3 plus 3. So 1/6 is our slope. M tan. Okay, so back to our line. Well, I lost the equation, but we had y minus y1 equals m sub tan x minus x1. Okay, so let's plug everything in here. So y minus 3 equals 1/6 x minus 9. And yeah, it looks like we have some fractions here. You always want to represent your answer in y equals mx plus b form, slope-intercept. So let's clean it up a little bit. Y minus 3 equals, now we're just doing arithmetic, 1/6 x minus 9/6, which is 3/2. So then I'll add 3 to both sides. Y then must be 1/6 x minus 3/2 plus 3. Well, I'm going to rewrite 3. I'm going to get a common denominator, 2/2. So that gives us 6/2 up top. So then this is 1/6 x minus 3/2 plus 3/2 plus 6/2 is positive 3/2. And there is the equation of our tangent line to the curve square root of x at the point 9, 3. Okay, and here we have the function in Desmos. So I've plotted the function there, and then you can see the tangent line comes in and just touches it just right at 9, 3 at the point 9, 3, and then goes on. So you can imagine as we move that point around our tangent, the slope of our tangent line, our tangent line itself would change, become steeper or less steep, depending upon the direction we move that point. But at least from this, we can see that at that point 9, 3, we have a very nice tangent line.